Hello everyone. Today in this video we are going to be talking about subtracting mixed numbers. In the previous video we talked about adding mixed numbers when we had a little bit more where the answer came out more than a mixed number, and then we had to do some manipulation to simplify it. This is on the flip side. In this case, when we start subtracting, we may have to borrow. So just to reiterate, on the right hand side, I'm just going to show you how you would work it out if you were working with a problem where you were taking all of the given fractions and mixed numbers and changing them into improper fraction to solve it. That option is always there. However, what we need to remember is in that option, sometimes our numbers tend to get extremely big. And to stay away from that, or just to work it out a bit more intuitively, we will be working with subtracting mixed numbers while keeping them in their mixed numbers. So on the right hand side, I'm going to go ahead and show you how it would work out if I'm just going to change this given problem and change it into a fraction and work with it that way. So let's see. The 5, we can go ahead and make it look like a fraction by putting a 1 under it, and then we can focus on our 2/3, and this will give me 3 times 2 is a 6, 6 plus 2 is a 8. This will give me 8/3 as my fraction. Now, if you remember, every time we're adding or subtracting, we have to add or subtract the like fractions. Currently, my first fraction has the denominator of a 1, and the second fraction has the denominator of a 3, which means they're not like fractions. To get to the like fractions, we have to find LCD, which is a 3, and then eventually change both the fractions to have the same denominator. So my first fraction, which is 5/1, can be multiplied with 3 top and bottom, and when we do that, I'm just going to go ahead and write it out here, which gives me a 15/3 minus a 8/3. Now, what we have to keep in mind is both of them have the same denominator, so I have the luxury of putting them up on a same big fraction to go ahead and subtract it. And when I do that, I end up with a 7/3, which eventually will give me 2/1/3 as the final answer. Now, this is a perfectly okay method to work with. The only drawback of this method is it requires a lot of going back and forth. We first change everything from mixed numbers into improper fractions. We find our LCD, we upscale, we subtract, and then the resulting answer has to be turned back into mixed number. It does require a little bit work, which is why we are going to look at the other method, which is the method of subtracting mixed numbers while keeping them as mixed numbers. So some things to keep in mind when we're doing that. To add or subtract while keeping it as mixed numbers, we align the numbers vertically. With the method that we just worked out on the right hand side, we align everything horizontally. But when we're working with this in mixed numbers, we're going to align it vertically. Always add, subtract from right to left. One of the few times you're going to be doing that in this course. Make sure the fractions are like fractions. That part is not going to change because that's the golden rule for being able to add or subtract your fractions. If the top fraction is not big enough, you may have to borrow. So to start off with, before we actually get in and start working with this subtraction, what I would like to do is with the picture just kind of go over the idea of what really is happening. So as you can see, I'm just going to go ahead and show you that we have 5 boxes on the right hand side, and for time being I'm just going to go ahead and show them to you here. So I have 1, 2, 3, 4, total of 5. Okay, now the thing is, based on the question, I am supposed to be subtracting 2/3 of it out. So I'm supposed to be taking that out. So what I'm going to do is everything that I need to take away, I'm going to circle it with the red. So this one, I'm going to take it out, toss it out. The second box, I'm going to go ahead and toss it out. That's my 2 full. For the 2/3, you're looking at the last one because I had already divided into 3 equal portions. Out of the 3 equal portions, we are supposed to be taking 2 of them out. So I'm going to take this one out and I'm going to take this one out. All the red ones are gone. What I'm going to go ahead and do right now is go ahead and put in the greens for the one that we're keeping. So if you notice, I'm keeping this one, I'm keeping the second one, and then I'm keeping the remaining portion from the last one. And if that's the case, let's start counting and let's start seeing what we left with. So I'm left with 1 full, the second full, and from the last one, out of the 3 equal portions, I'm left with 1 equal portion, which gives me my 1/3. And guess what? We end up with the exact same answer conceptually as we did earlier, working with the numbers. And that was our goal. So that's really what happens when you are taking your full whole number and subtracting a mixed number out of it. Okay. Let's move on. Before we get in and actually start working on the problem, I would like to show you something which tends to be a common mistake and something that we should not be doing in a problem like that. So the problem is 5 minus 2/2. So I'm going to go ahead and write it down. A common mistake that people make is they come in here and look at the fraction going from right to left and they say, okay, I have a 2/3, I have nothing on top of it, so when I subtract it, I end up with a 2/3. I subtract a 5 and a 2 and I end up with a 3. If you notice, if that really how we needed to work the problem was, then we would have gotten the same answer as we did with the previous 2 methods. This gave us a 3/2, not the same as 2/1. So it's completely different and we can't do that. Now what I do understand is sometimes the idea is stemming from the addition problem that we did work in one of the previous videos. In an addition problem, we're saying I am adding a 2/3 with nothing. If this was an addition problem and I'm talking about adding a fraction with a no fraction, with a zero fraction, or with nothing being there, I'm able to do that. And in that case, if you were adding 2/3 added with nothing, still leaves you with a 2/3. And obviously the 5 plus 2 will give you the 7. However, let's think back in subtraction. If I need to subtract, I cannot subtract out of nothing. So this goes back to the basic subtraction rule, which is if I'm trying to subtract and the number on the top is not big enough, in this case it's a nothing, so obviously it's a 0, it's not big enough, we have to borrow. So that's what we have to work on when we work this problem out. So let's actually work on this. So my problem is 5 minus 2/2. Okay, so obviously we're resorting to borrow because 2/3 going from right to left. We start subtracting the 2/3 and there's nothing on top of 2/3. So, and I'm going to go ahead and put a box just to represent that I have nothing over here right now. If the box is empty, we have to go to the next door neighbor, which in this case is a 5. Now what I want you to kind of keep in mind is if you're borrowing from a 5, 5 is a whole number. The only thing a 5 can ever give off to us is a whole number. So technically when you borrow from a 5, it splits into a 4 and a 1. So remember, it's a 4 and a 1, which is really a 5. So you're not changing the numbers. You are simply just rewriting it in a different way. I'm going to just go ahead and rewrite it so we can see a little bit better. So I have a 4 and a 1 split together, and right under 1 is my 2/3. Now, the situation comes out is we have a 2/3. We need to subtract a 2/3, and we can only subtract things, fractions with fractions, add fractions with fractions to make things simpler. What you have on top of your 2/3 is really not a fraction. It's just a simple whole number 1. So what we need to start thinking is, what can I do? How can we rewrite that 1 to make it in a best format to subtract with the 2/3? So I'm going to go ahead and start thinking about it. 1 can be written out as a 1 over 1. It can be written out as a 2 over 2. It can be written out as a 3 over a 3. It can be written out as a 4 over 4. So essentially, a 1 can be written out as the same number, top and bottom. Which one do we pick? That depends on the fraction that we need to subtract out of it. So if you look at the 2/3, it has a 3 in the bottom or the denominator. So the best thing for us to do is to pick a form of a fraction which already has a 3, so we don't have to worry about finding an LCD and going from there. So the best one to pick will be the one with the 3 over 3. I'm going to rewrite it, and what you need to keep in mind is, I'm just rewriting so that way it's not a big mess. We never changed the given problem. We just wrote it differently. Instead of writing a 5, which was the original problem, we rewrote it as 4 and an equivalent of 1, which is a 3 over 3. Now, going from right to left, we can go ahead and subtract. 3/3 minus 2/3 gives me my 1/3, and 4 minus 2 give me my 2, and we can see that's our final answer. And if you go back, let's just go back and double check, that is exactly the answer we had gotten with the other 2 ways we did it, when we changed everything into fractions or when we did it conceptually. So that's the answer for this one. Okay, now let's move on and let's work with a problem which may be a little bit more involved. And in this case, we are subtracting the mixed numbers while keeping it in a mixed number format. We're not changing it into fraction. And because we're doing that, we're going to go ahead and write everything vertically, because that's what makes it the quickest or easiest on our eyes to see, basically. Okay, we look at this, we look at a fraction, and our fractions are not like fractions. In order for us to subtract for this problem, we have to prepare our fractions to be like fractions, which means we have to find out the LCD of our 6 and 3, which happens to be a 6. So the goal now, the purpose of finding the least common denominator, is to change each fraction to have that as the denominator. Now, if you look at the first fraction, it already has a 6 as the denominator, so we have nothing to worry about. But the second fraction has a 3 as the denominator, so in this case, we are going to be upscaling it by a 2. Remember, just the vocabulary, upscaling is when you pick one number and multiply top and bottom with that number. When we are upscaling a fraction, we're not changing its meaning. We're not changing the shaded portion. We are just making the numbers look bigger, i.e., if you were to draw a picture, portions look smaller. You're not changing the interested portion or the shaded region. So let's rewrite. I have a 15/1/6, and I am ready to subtract my equivalent fraction, which is 9/4/6. Should be able to subtract, right? Uh-oh, Not really, because I cannot subtract a 4/6 out of 1/6. We have something divided into 6 equal portions, and I am interested in subtracting 4 when all I have is one little portion left. Once again, my top fraction in this case, as opposed to a no fraction in the previous problem, my top fraction is not big enough. And since that is the case, I have to resort to borrowing from the next door neighbor. And once again, I need to borrow from 15. And 15 is a whole number. So remember, because it is a whole number, it can only allow you to borrow a whole number. So the 15 splits into 14 and a 1. I'm going to rewrite it so we can not have a big mess here. But as I'm rewriting it, I want you to stop and think for a second. You are borrowing a 1 from that whole number. The whole number can only give off a whole number. When we borrow the 1 for the 1/6, where do you think we need to place that number 1? Should it go in the numerator, on the side, or on the denominator? I want you to think about that. Because remember, 1/6 is not a whole, it's a portion. Okay, so with a different color pen, I'm going to go ahead and write out where the 1 is. Yes, the correct answer of putting a 1 is on the side, because 1 is a whole number 1. With the given format, it doesn't belong on the numerator or in the denominator of the fraction, and because it is a whole number, it only belongs to the side as a whole number. Now you must be thinking, whoa, we started off with a simpler mixed number. Oh, I have to apologize. This should have been a 14 rather than a 15. That'll change things. We started off with mixed number, and we changed it into something a little bit more complicated. But let's focus on what we're doing. We need to sort of clean this 1/1/6 so we are able to go ahead and subtract the 4/6 out of it. In the bottom, I'm just going to rewrite it here. All I'm going to do is rewrite that mixed number. We have a 14 here, and one of the ways to simplify is changing that 1/1/6 into a mixed number, which gives me a 7/6. If I have a 7/6 on the top, and then I have a 9/4/6 in the bottom, our numbers are good enough to be able to subtract. If you're wondering why do we have an improper fraction in the middle of a mixed number, it's okay to have that since we are in the middle of working on a problem. And keep in mind, it's not okay to have that as a final answer, because all final answers have to be simplified. So in this case, it's okay. We're going to be subtracting the 4/6 out of the 7/6. When we do that, we end up with a 3/6 over here. And we subtract the whole numbers, which 14 minus 9 leaves us with a 5/3/6. So that's the mixed number we end up with. But remember, any answer we get with a fraction or mixed numbers have to be simplified. And in this case, the fraction can be simplified. The common factor between the numerator and the denominator is a 3, and 3 can simplify both of them into a 1 and a 2. And we can come out and we can write the final answer in its most simplified version, which is 5.5. So that's what we end up with when we started off with working with something that was a 15/1/6, which was a tad bit bigger than 15, and subtracting a 9 2/3, which was much closer to the 10. So we're ending up with something in the vicinity of 5, but a little bit more, and to be exact is 5.5. Thank you for watching, and we'll see you again. Thanks.